Okay.
Hi everyone, this is my first video on YouTube, I guess, and my name is Brian. I'm just gonna introduce you to my lab here, my mini lab at home on mechatronic projects. After my graduation, I have quite a bit of time, so I decided to design something fun using Arduino board and some step motors. I was trying to build a 2-axis, 2 degree of freedom CNC motors or CNC platform. This is the step motor right here, and this is Arduino. Arduino is very powerful. It interacts with the actuators and sensors, controlling them, putting in logics and all kinds of fun stuff. But I realized in order to drive this motor right here, I have to buy a H-bridge to drive it. So I just bought it off eBay. And it hasn't been delivered yet. So I guess I need to wait a little bit. So I designed a CNC platform using my Lego Mindstorm to just kind of test out my prototype design. I will demonstrate how it works to you guys just in a moment here. But first I need to explain the mechanism behind. As you can see, these two, oh yeah, by the way, this is my finger, just to be precise. These two are my motors producing rotational motion. But in order for it to move in translational, which means a linear motion, I have to use a worm gear in here, or worm gear. They are identical, like this box and this box are identical. And this is a worm gear here, and when it rotates, it drives these two washers up and down, basically along with their axle. And the axles are attached to a platform, so the axle will actually go left right there. Once it's activated, you will see. You should be able to see clearly how it actually works. It's very simple. In fact, you can buy I think Lego Mindstorm actuator, but I'm kind of cheap. I just want to kind of design it myself, the whole system myself. So yeah, this is actually pretty fun, funner than that pre-made actuator. So let me just demonstrate how it works. I have a piece of paper here. As you can see, it's already drawn. This is my first testing. Yeah, I would just see this piece of paper as a workpiece on the platform, and the pen right here is actually act as a cutter, a mill cutter or other cutter that can cut stuff. So with the path it draws on this paper, we know the path it cuts. So let me put the piece of paper in there first. So if it does correctly, it should draw a box light kind of thing. But this system is not very accurate because everything is made of plastic, and that's as far as the Legos can go, right? So now let me lower this cutter so it can actually touch the paper. Alright, oops. So now it should be touching. Oh, I'm sorry for some inaccuracy right there. Okay, I'm gonna fire it up and explain it just a little bit further. So now, as you can see, this washer is going up along with the axle attaching to a washer, and then it's going back down. The worm gear is driving this up and down, and as you can see, it's already drawing a box right there. And although it's not really accurate because you see the path going up and going down, it's not identical every time in every cycle. But then yeah, I can probably fix it later, or the actual system will be much better using a step motor, because step motor is very accurate. And you can see there is a button right here, a button. Once this button is depressed, the platform will go backward. This button is very important because you don't want the platform to go too far away, because it can be very catastrophic, because the motor will go on no matter what. So if it doesn't go backward, the plastic will actually break, or the whole platform will fall apart. And here, same for here. It also has a touch sensor here. Once it's depressed, once this sensor is depressed, the platform will go backward, just like the other one. But as you can see, this can move in X and Y axis, like when you press, and it's going backwards. So this can move in Y and X axis. So I call it a two degree of freedom CNC platform. Now the paper is quite messy because this workpiece is not really affixed to this platform here. But yeah, that's okay. It's just for demonstration purposes. Okay, all right, that's it.